Well, good morning. Thank you all for joining us. We still have a few folks that are getting on the call, but I just wanted to start in interest of time. My name is Dr. Stormy Monks, and I want to welcome you to today's Grand Rounds presentation hosted by the Southwest Center for Pediatric Environmental Health. So the Southwest Center for Pediatric Environmental Health is one of 10 PACEUs in the United States. These are Pediatric Environmental Health Specialty Units. The purpose of the PACEU program is to serve as a leading national source in medical information and consultative service on environmental conditions that influence human development. To serve as part of our mission, we offer this Grand Round series once a month on the third Thursday of the month. We're grateful today to be joined by Dr. Chris Wiant. He will be speaking on exposure to forever chemicals. But before we start, I would like to make sure we have a few housekeeping items addressed. So will not be able to share your video and you will not be able to unmute during the call. But if you have any questions or comments, please put them in the chat box. At the end, we'll be sure to bring those up to Dr. Wyant to make sure that your comments and your questions are heard. So now, without further ado, I'd like to thank again Dr. Chris Wyant for coming today and speaking on forever chemicals. Chris Wiant retired in April 2020 as the founding president and CEO for Caring for Colorado Foundation. Prior to joining the foundation, Dr. Wiant was the executive director of the Tri-County Health Department, serving the residents of Adams, Arapahoe, and Douglas counties in metropolitan and rural Colorado. For 13 years, he served as the Deputy Director of the Tri-County and the Director of Environmental Health. Prior to coming to Colorado, Dr. Wiant worked for the Illinois Department of Public Health, where he was responsible for multiple programs addressing human health effects of exposure to toxic substances in their environment. Dr. Wiant has been involved for the last several years in issues of national, state, and local public health and environmental policy. He is an adjunct professor for Texas A&M University through Texas Engineering and Extension and the National Emergency Response and Rescue Training Center. He also has served on the ad hoc committee for the National Academy of Science, Engineering, and Medicine to study the human health effects of PFAS. So again, we're very fortunate to have him here with us. And thank you so much, Dr. Wyant, for being here.
Very good. So welcome everybody, and it's always a challenge to give a lecture and not see who you're talking to, but we'll do our best. This is really a follow-up, kind of an update of a presentation I made a couple of years ago, because a lot's happened in the world of forever chemicals and PFAS. And so I'm going to talk today about the new science, kind of some new protections, and like you might expect, some new challenges. We'll talk a little about the history again and the characteristics of forever chemicals, for those of you that aren't familiar. Review the science and the health effects, what's known presently about health effects, common sources and the prevalence of forever chemicals, exposure, so the public health challenges in reducing exposure. And one major difference that's happened in 2024 is the PFAS regulations that have come from EPA regarding drinking water, and then an important Supreme Court decision that has overturned what's called the Chevron decision. We'll talk more about what effect that might have on future environmental regulation of chemicals like PFAS, as well as other environmental chemicals. So PFAS, per and polyfluoroalkyl substances, PFAS. That's a class of chemicals. It begins to get confusing when they get to individual chemicals and you see all the various names. But when you see PFAS with an A, that's the overall class called forever chemicals. And these are characterized by strong carbon-fluorine bonds. Like a lot of carbon halogen bonds, they become quite an environmental issue because of the persistence due to the strength of those chemicals and their long chains of carbons. Getting more specific about the forever chemicals, there are generally three categories that are considered. One, fluorosurfactants, like PFAS and PFOA. Those are common names that you may be familiar with or may hear about. Fluoropolymers, and that's really what started it all. Polytetrafluoroethylene resin, which is Teflon, which is used in also used in aerospace and medicine, and fluorocarbons, which might be common for everybody that was used a lot in refrigeration, air conditioning. The fluorocarbons have been pretty much taken out of the refrigeration world now and substituted with other less environmentally challenging chemicals. For those of you who miss your organic chemistry class, I thought I'd show a couple of pictures. It just gives you a sense of what these chemicals look like. It's kind of a standard formula where you see the carbon and the fluorine atoms, and then on the end is typically one of these three groups. So these all fit in that category of PFAS. And the real difference is how many carbon atoms are exist and how long those chains are. And that has a lot to do with how persistent they may be and or how easily or not they may break down. And that then goes to health effects and environmental concentrations. There are some 5,000 plus different PFAS chemicals. As I said, some long chain, some short chain. And that's really part of the challenge. There are many chemicals with similar characteristics. The problem is we haven't been able to study but just a handful of them. So we really don't know what the full extent of the potential risk might be and where all these chemicals may be because we've only been able to identify and study and measure certain ones, but we know there are a lot of PFAS chemicals out there. The thing that makes them unique, both from the standpoint of why they're so valuable as a product in manufacture, as well as why they're such a problem in the environment and in human exposure, is they're hydrophobic and lipophobic, which means they resist grease and oil and water. Yet, because of their stability, they're persistent and they're bioaccumulative. So when you do consume them, they don't tend to clear from the body very readily. So as I say, that makes them like the Teflon pan. That makes it really good for cooking, but doesn't make it so good for the environment. The half-life of these chemicals, again, showing you sort of the range of how toxic or non-toxic they may be. The half-life is ranges from 1/10 of a year to 35 years. And you may recall there have been a number of other chemicals over the years that have been dispersed in the environment that are persistent, like the chlorinated chemicals, the pesticide DDT, for example, PCBs. There are a number of similar chemicals that have created quite a problem in the environment and as a result of human exposure because of their half-life, how long it takes them to break down into their component parts. What we know is that PFAS are widely dispersed in the environment, and you'll see a lot more of that as we go. And they have been associated with health effects through animal and human studies. The challenge is to really find that cause and effect and dose response to know exactly what the risk may be based on what level of exposure. And we'll hear lots more about that. Kind of did the history. So in 1938 is when the first PFAS chemical really was identified, and that was tetrafluoroethylene. A scientist at DuPont was working with freon gases, and as often happens with new discoveries, it was kind of an accident. He discovered in a frozen sample of tetrafluoroethylene that there was a solid waxy substance, which we now call Teflon. It was a slippery, stick-resistant substance. So it was identified and suddenly became quite a popular chemical as they realized all the characteristics it had. And of course, in the 1930s, we didn't have nearly the capacity that we have now for studying these chemicals. And like we find now, many of these chemicals, the human health potential wasn't identified, and there just was so little we knew. And it was all about manufacturing. And if we found something that like Teflon that could change a marketplace, that was the issue. It wasn't, well, maybe we better check this and see if it has any effects on humans. It was assumed that it would be otherwise inert, and we now know that's not necessarily the case. Here's a timeline that gives you an idea. It really points out a couple of important things. First, the 30s and 40s, when some of these chemicals really came to be and they realized they had commercial uses. So in the 50s is when manufacturing and commercial production really began of using the PFAS chemicals for a variety of things. You'll see a list of those shortly. So that was the 50s through really the present time. You see in 2000s, they began to phase out and look for alternatives for these PFAS chemicals. Because in the early 1960s, we began to have concerns about health. And that was back when we really didn't make a very fast connection between the manufacturing world, the industrial world, and the human health world. As you can see here, in 1961, DuPont scientists, so in the manufacturing industry, they realized that they were doing some testing of PFAS and realized that it caused liver enlargement in rats. By 1978, continued testing showed that employees of the DuPont factory that were working with PFAS reported high rates of abnormal liver function. In 1982, finally, it was the DuPont medical directors decided they should really begin to reduce exposure to PFAS. So you see the time there, there's a good 20 years before from the first time they recognized there might be an issue, 20 years before the manufacturer decided to do anything. By 2003, 2.5 million pounds of PFAS had been dumped. In this case, had been discharged into the river that was right beside the factory in West Virginia. But it wasn't until 2017 that they really finally were called to task, and as a result of a lawsuit, had to discontinue that discharge and take care of exposure from downstream community water supplies. We'll kind of see how that happened here shortly. And then at the same time, with this DuPont factory, a panel was created to really begin to study the health effects of PFAS. So if you go back here, it was identified in the 30s. It was potential health effects were identified in the 60s. And it was really in 2017 before it really became an item that was on people's radar and the regulators' radar about this is something we should deal with. So, it was 50, 60, 70 years in coming. Part of that was because the laboratory technique wasn't available to really measure these chemicals at some of the low levels they might be seen, and both in humans and in the environment. So on some level, you can say, well, we didn't have the capacity to be able to measure some of this. On the other hand, we did have suspicions. Scientists did have suspicions that PFAS caused negative health effects and might cause environmental issues also. So where are PFAS found? Probably the most the largest single source is what's called AFFF foam, so aqueous film forming foam used for firefighting. This material is used particularly around airports, because it's particularly good at suppressing fuel-related fires. And so early on, AFFF foam was used with standard bunker gear that firefighters might use, but there was a lot of exposure because uh, firefighters would be literally sprayed down with AFFF foam as they were fighting the fire. And then there was the risk of inhalation of airborne contaminants from the foam. And then once that occurred, the foam residual would tend to be washed into the soil surface or into surface water, or find its way down to groundwater eventually. So AFFF foam became a huge source of environmental exposure to PFAS, and in certain industries like firefighting, it became a primary source of exposure, chemical exposure to individuals. Also found in food packaging, personal care products, construction materials. You kind of get the hint here. It was used in almost everything. Cookware, obviously, the Teflon, textiles, upholstery, carpets, uh, and subsequently in the environment, and particularly concerned about drinking water and soil. So it's truly the ubiquitous chemical. It's found everywhere. It's not just something that's manufactured, goes into a product, and once that product is disposed of, it's gone. But PFAS chemicals have found their way into the environment and into a number of places that they might otherwise be if it weren't for things like groundwater, surface water, and soil. Here's a depiction that kind of gives you a hint of all this work. So up here in the upper right-hand corner, you see a manufacturing site. So in the case of DuPont, their waste was discharged into the river. Remember, back before the late 60s, there was no Clean Water Act. And so there was very little regulation of discharge from a manufacturing facility into the river. You might recall long ago the Cuyahoga River in Ohio that caught fire because of the contaminants that came out of industry. So that's where that 2.5 million tons of PFAS got into the water, into the surface water. And if you go downstream in that particular case, here's a water treatment plant. So they draw out the raw water from the stream, run it through their treatment plant, which at the time was not as sophisticated as water treatment is today. So then it gets into the drinking water for the community. Or the sludge of the byproducts from this wastewater treatment plant may be applied to, and then you run the risk of infiltration into the groundwater. And you also see the airport, as I mentioned, you get the airplane fire, you use AFFF foam, it washes off, it could run into the river, could run into the ground, could run into other surface water sources, because originally there was no control over that. There was no such thing as a stormwater regulation that said, here's how you have to manage this residual. Again, public drinking water supplies, private wells that would be contaminated from the groundwater, consumer products in homes. So it just gets the picture that the stuff is everywhere, and how easily it can be transmitted through the environment and to human exposure. Here's kind of another angle of that depiction, and maybe gives a little better picture of air, sediments, biota, surface water, from the surface water to the groundwater back to other surface water. Just the cycle of contamination is pretty thorough, and that's what really makes it so that this testing they have done, every time they've looked for PFAS chemicals, they found them in whatever environmental medium they might choose to test. So what do we know about human exposure? Well, there's a thing called NHANES, the National Health and Nutrition Examination Survey. And NHANES is used to really get measurements of various kinds to identify the prevalence of disease or risk factors for disease. And so this national survey in the 1999-2000 year began to test for PFAS chemicals to find out, can we find out what the prevalence of PFAS chemicals is in the population? This is a nationally representative sample, so there's statistical validity to it to give you an idea of a national picture of what PFAS exposure might look like. And as you look, the good news is, this only goes up to 2016, but the good news is these concentrations have reduced generally over the years. Up here in the corner, you see the 9 different specific chemicals that they measured. But they also found that greater than 99% of the participants had measurable levels of PFAS in their blood. So that basically says everybody in the general population has been exposed to PFAS in one form or another. What we didn't know at the time, what we still don't really know, is what levels in the blood present what level of hazard. But we continue to look at that. Another example of how this NHANES works is I use this example of blood lead sampling. Notice in your next speaker is going to talk about lead. The same kind of sampling was done for lead, and it really led to the development of policies that has caused a huge decline in blood lead levels in humans. Once we knew how widespread the exposure was, we began to be able to find sources, look for health effects, and ultimately lead to regulation, testing, analysis, and treatment of lead poisoning, and particularly in children. So NHANES could provide some of that same value for PFAS, that we know where it is, we can see what sort of intervention might be possible, and then we can measure whether or not those interventions are working by continuing to measure levels in the population. There's a real challenge with childhood exposure and a real concern about that from researchers. They do know for a fact that PFAS chemicals can be transported through the placenta. They do know that it's found in breast milk. They do know that consumption of contaminated drinking water through baby formula is a source of PFAS exposure. They suspect hand-to-mouth behavior on surfaces that have either been treated with PFAS-containing chemicals or PFAS that may be in the dust that is on those surfaces. So the inhalation of that dust. The uncertainty that remains is what the effect is and the long-term result of exposure. And that's really kind of the crux of where we are with PFAS in general now is what does all this exposure mean? What level of exposure is important, and what outcomes should we be looking for, and therefore what treatment might be effective to prevent those outcomes. The C8 panel I mentioned before is a result of the DuPont plant in West Virginia. Their charge was to carry out exposure and health studies in that region, the Mid-Ohio Valley communities that may have been affected by the release of PFOA. It's called C8 because PFOA happens to be a chemical with 8 carbons, so they called it the C8 committee. And it had been emitted in that area since the 1950s from this Washington Works in Parkersburg. And so their job was to study the population and see what they can learn. Now, this committee has since been disbanded, but they did have results. And what they learned was that there's a probable link based on the weight of the evidence that establishes a general causation that's more likely than not that there's a link between exposure and one of these conditions: hypercholesterolemia, thyroid disease, ulcerative colitis, testicular cancer, kidney cancer, pregnancy-induced hypertension. So these were the findings a few years ago that came out of the C8 panel. And this has really provided the basis for some additional research to try to figure out not only if the exposure has occurred, but try to come up with some sort of a dose response relationship that said, if in fact these diseases are caused by exposure to PFAS, what type of exposure is required and what's the ultimate outcome in terms of disease. Since that time, you see on the left, the animal studies have identified, again, liver effects, immunological, developmental effects, thyroid or endocrine effects, reproductive effects, and tumors. Human associations, again, not causation yet, associations have been liver, cholesterol, immune system, developmental effects, again, thyroid effects, cardiovascular, and cancer. So we've increased the list of concerns in terms of what's expected to result as a result of PFAS exposure. Now, one of the challenges is, as you can see, there are many causes to all of these things on this list. So the question becomes, was it PFAS or was it something else, another circumstance that resulted in this effect that may be seen in somebody who has an exposure history to PFAS? In terms of occupational exposure, obviously chemical manufacturing, firefighting, and curiously, there's been some work done with ski wax technicians because PFAS are found in ski wax, and they tend to heat the ski wax up, and the vapor from that disseminates the PFAS into the air, and so those ski wax technicians may be exposed. And some work is going on to try to characterize that more thoroughly. The problem is we have some issues still with current analytical methods that are not robust enough to really capture the full potential range of PFAS across different workers and workplaces, whether it's measuring the individual chemicals, whether it's being able to measure chemicals in various media in the human body or various tissues. There are a variety of challenges associated with this because often we're looking for fairly small concentrations in terms of just the pure numbers. And so making that association becomes a challenge. This is an interesting list of the research that's going on now. You see on the left, these are just a handful of PFAS chemicals that have been identified and have been subject to some study. As far as the colors, the green color is human studies, the animal studies are in blue, and in vitro studies are in orange. So you can see there's a lot of work going on. Up on the top, you see the various organ systems that are being studied. So while we have a lot of speculation about what some of these risks are, you can see there's a lot of work to be done to really come to conclusions. And then once they come to conclusions about cause and effect, then to come up with some kind of a response to try to reduce the risk. So one of the things that's occurred over the last few years has been, as states and as the federal government have recognized, one, the distribution of PFAS literally throughout the country, and two, the potential hazards that have been identified, the risks of human health risks that have been identified. States have begun to do some regulation based in part on speculation and based in part on on the science that has come about to try to get some idea of, so what level do we regulate to, depending on what it is we're regulating, whether it's drinking water, other environmental media, human health, food, whatever it may be. So 28 states, as of was compiled in March of 24, 28 states have laws concerning the use or manufacturing of PFAS. A lot of the laws involve water and firefighting foam, carpets, textiles, and cosmetics, things where they believe there are substitutes for these substances. And water, obviously, because that probably is a primary source of exposure for humans all through the country. So there's beginning to be some regulatory action. Again, just this is not uncommon for environmental contaminants discovered in 1938 and finally in 2024. The regulatory system has begun to catch up and has begun to develop enough evidence, because you can't just say, I want to make a regulation, because they're those who make the chemical and use it and sell it are going to fight regulation unless it's based on a good scientific basis. And so it's taken this long really to make the case that some level of regulation is appropriate to begin to reduce the prevalence of these chemicals in the environment. This year, in 2024, the US EPA has developed a drinking water standard. It used to be that until this year, EPA had a health advisory for some of these chemicals, which was really a recommendation. It wasn't a enforceable standard. It was a recommendation, health advisory of 70 parts per trillion in drinking water as a lifetime health advisory. That was the best they could do with the information they had. Already, as of 2024, you can see what's changed. They now have enough information, they believe, for at least these two chemicals, PFOA and PFAS, to develop what's called a maximum contaminant level of 4 parts per trillion, considerably less than the 70 parts per trillion of the lifetime advisory. The maximum contaminant level is not necessarily the level they consider absolutely safe. It's the level that also takes in feasibility, cost, whether or not there's technology in the water arena, the drinking water arena, whether or not there's technology that can take this contaminant out of water down to a level of 4 parts per trillion or less. The maximum contaminant level goal is 0. And that means that EPA really like to have a standard of 0, but they know it's not feasible. So if the standard was 0, then basically most water utilities would be out of business, or they'd be in violation because they couldn't meet the standard of 0. They could potentially meet the standard of 4 parts per trillion. So that's EPA's signal that says, we don't think any of this is safe, but this is the best we can do under the current circumstance. Or another set of PFAS chemicals, they set a maximum contaminant level of 10 parts per trillion and a maximum contaminant level goal of 10 parts per trillion. So the determination is that if you reach this goal, then you've reduced the hazard to an acceptable level. And that would be the same as the regulatory level. So you have to meet the 10 parts per trillion, and that at this point, that would be considered adequate. The new health advisory, which again is for a lifetime exposure to drinking water, is 0.004 parts per trillion, which if you compare to this would be 4 parts per quadrillion. Now the challenge is measuring 0.004 parts per trillion is is something that's hard to do. So again, that's a health advisory, and that again is EPA saying we really think zero is the answer, but we're going to get as close as we can get to it. And this, the 0.004 parts per trillion becomes the goal uh, for the lifetime advisory. So if you're drinking contaminated water every day for your entire life, they're saying that you've got to be at that 0.004 or less in order to be safe. Again, that's based on the current weight of the evidence. That's not based on a definitive standard that says we know for a fact that below this level is safe and above this level is not. One of the challenges with any environmental chemical is getting the absolute answers that says we know absolutely we're safe below this level. We know we're not safe above this level. It's rare that we come to terms with that, and it's often rare that we can actually measure down to the level where we think there might be absolute safety. So sometimes the challenge, and maybe the challenge for all of you, particularly in the pediatric world, is when somebody comes in and says, what's this about PFAS? And I'm concerned that my child's being exposed. So what do you do about it? And there's been a lot of work on how to engage with communities. One thing for certain that you should be aware of is community residents know a lot more about these things than they used to. And in a lot of cases, communities may know more than the providers know because they've done that research. Now, granted, sometimes that research isn't the scientific basis for some of that research is questionable, but nonetheless, people come in with a definite perspective on things like PFAS and what it may be doing, and they come in with the expectation that zero exposure is the only answer to the question, that there shouldn't be any exposure to a chemical like this that may cause harm, particularly if they're looking at causing harm to their child. So what is recommended is for individuals to learn about potential sources of exposure in the community. One way to do that is in the drinking water is to go to the water utility and say, I want to see the consumer confidence report because you should be measuring PFAS in your drinking water, and you're obligated on an annual basis to make a report to the community that identifies the levels of various chemicals that you find, various hazards that you find in your drinking water. And so there are ways to find out if there is a potential source of exposure through drinking water. What's manufactured in your community? Are PFAS chemicals used in that manufacture? Where else might they be? So you can get some idea whether or not in your community there's a greater or lesser risk of exposure. Sometimes contacting a primary care provider to discuss exposure history. So if somebody says, I was a firefighter for 20 years and I used to work at the airport, and yeah, I used AFFF foam, the provider then could take that history and do what they do, which is to do the proper monitoring to find out whether or not they can find any association with that exposure and some potential health effect. On the other hand, if there really isn't a known exposure history, then that also gives the provider good information. You can provide recommendations or look for recommendations for reducing exposure. We'll have a few of those here in a minute. And promote age appropriate preventive care. A lot of these chemicals, the PFAS chemicals, show up as aberrations on standard testing that might be done anyway. So if you get a full blood panel and you get indications of liver, kidney, the various organ systems that are tested in routine preventive care. When you see levels that are out of the normal range, it can begin a conversation about, well, what might that be? And you you don't necessarily go right to PFAS, but at least that's the way that you may begin to find out whether or not people have been exposed to these chemicals and whether or not some additional follow-up should take place. As I say, the community members are often well informed, and they may come in with data from the internet that shows what their potential exposure is. Ways to avoid PFAS, unfortunately, it means you got to not do a lot. Avoid stain-resistant carpet and upholstery. Avoid products with Teflon, which means cookware made of other materials. Filter your drinking water using carbon or reverse osmosis. Eat more fresh foods, avoid takeout. There's been a lot of talk about food packaging and the risk of food packaging, not only now from standpoint of PFAS chemicals, forever chemicals, but also things like microplastics. So there's a whole new world out there of hazards to food packaging. Microwave popcorn has been identified as a pretty significant source of PFAS in everyday products that might get into the household. And in the community, it's questions of who you talk to learn more, what your state might be doing to address PFAS, and can give you some sense of if they've identified PFAS in drinking water, what's been done about it. If they identify it in the surface water, what's being done about it. There's a variety of ways to get information about what the community risk might be, as the people downstream from the DuPont plant did. When they did their research, they realized that plant was putting out a fair amount of PFAS materials into the surface water in the stream, and then they traced it to their drinking water supply and went from there. As far as drinking water, the good news is it can be addressed. In large systems, they typically granulated activated carbon or reverse osmosis are the types of treatment that they use. Those are also available in individual treatment units, what we call point of use devices. A point of use device that is recommended should always be certified by a firm called NSF International. It's kind of like Underwriters Laboratory. They certify that a point of use device acts as it's supposed to, that it actually does remove the contaminants. Again, I mentioned the Consumer Confidence Report. In the case of baby formula, obviously use non-contaminated water, or through a point of use device is to use that filtered water to mix that formula. And as I mentioned, the remedy now is with this maximum contaminant level. The good news is there's a standard. The less good news is that utilities are given several years to come up to meet that standard. And so it's not an overnight thing. All of a sudden, all the drinking water is not going to be free from PFAS chemicals. It takes some time, and the larger the community, the less time it takes. The smaller community, the more time it takes. And so we can't expect that those levels are going to be reduced. If they have high levels, they're not going to be reduced in a really short period of time. So the remaining challenges with PFAS, and you can really substitute a lot of different chemicals in here, because this is sort of the public health challenge of a lot of environmental chemicals. The growing concern that contamination is found wherever they look. Environmental justice issues, where A lot of these manufacturing sites may be in marginalized communities. Absence of really comprehensive monitoring data, the persistence in the environment, and then the challenge of tracking the source of exposure. Some of these areas have been contaminated. It might have been 30 years ago, and things have changed since then in terms of where the exposure may have come from. In the case of forever chemicals, the big challenge is unknown mixtures of chemicals and the chemical and toxicological characteristics. Because there's so few that we've studied, we can't make assumptions that they all act the same. And so there's so much work to be done to really identify what the risks are. And that gets to the lack of research results. While we know a lot about these chemicals that we didn't used to know, we still don't have really good dose response data, really good correlation between exposure and health effects, and therefore we lack good clinical guidance other than avoidance. Try to avoid exposure, but we lack good clinical guidance in terms of how to really address this. So bottom line is too much uncertainty and too few facts. I already mentioned a number of chemicals studied. The public concern, sort of balancing public concern with sound data, that's where the regulators have the challenges, is the call to regulate these chemicals, but they've got to have solid science in order to be able to do that. And then, as I've just mentioned, the time and the cost for full implementation of a new rule. So that could be 5 years, maybe as much as 10 years down the road for some facilities. So the final thing I'll talk about is sort of the change that isn't just a forever chemical, a PFAS issue, but it really could potentially affect all these things that are based on science, that come from regulatory agencies. Back in 1984 was a Supreme Court decision, Chevron versus Natural Resource Defense Council. And the bottom line was Congress said that if a law is silent or ambiguous, as determined by the court, then the courts, their obligation was to defer to the agency's reading of the statute, and basically saying, like the Clean Air Act was passed in the late 60s. It was a general statute that basically gave EPA, well, now EPA, the authority to regulate airborne contaminants. It didn't list every single one they could regulate, didn't list exactly how they should regulate it. It really left a lot of discretion and called for the science really to be the arbiter, that if they could demonstrate that what they were trying to regulate was in the spirit and the context of the statute, then they would defer to the agency in terms of what level of exposure or what level of regulation was appropriate. So the bottom line was they defer to the scientists and the experts in the agency. So if XYZ company decided to object to a particular regulation, the court's job was to see what the scientists had to say. The scientists would demonstrate that their thinking was valid, and the court would say, we defer to the agency and this regulation stands. In 2024, the Loper Bright Enterprises decision by the Supreme Court, they said Chevron was wrongly decided, that the plain text reading of the Administrative Procedures Act suggests that the court should decide all relevant questions of law. So again, back to these somewhat historical federal laws in particular, that if the agency decides that some should be regulated, then instead of being able to make the scientific case, publish in the Federal Register, and the regulation goes through, if there's a protest now, the judges are saying they get to decide. Supreme Court says the judges should decide all decisions of science, which really could potentially, I mean, they can still defer to the agency, but potentially takes the science out of it, and it could become much more, if not political, at least biased in terms of a judge's own perspective on whether or not a regulation is reasonable. This obviously is a new decision, hasn't really played out yet, but there's a lot of fear that either that the judges, that the judicial system will make final decisions, and that Congress would have to be much more explicit in the way that they give agencies like EPA the authority to regulate chemicals or regulate anything. And then all of a sudden, it becomes much more of a political issue, and where Congress could be lobbied to do something or not do something. And they too could basically ignore the science. That's the fear. Whether or not it pans out is another question. So, back to things like PFAS, if there's a determination that there should be a more stringent regulation, there could be a difference now in how that finally gets adjudicated. So, a few slides here on just where you can find more information if you're interested. I'll point to the one on the bottom, National Academy of Science and Engineering and Medicine, put out a report in 2022 that really was a pretty contemporary look at the research was out there. It was specifically aimed at trying to address an update of clinical guidance for PFAS exposure. And there's a lot of good information and data in there that if you're really interested in getting into the details, that's probably the most contemporary compilation of information that's out there that has direct value to practitioners. Otherwise, CDC, EPA, NIHS, they all have got a lot of information now about PFAS as it's become more prominent. Other references for occupational exposure and general references for what we've done, and these all I suspect will be accessible from Dormy if you'd like them.
Thank you, Dr. Wyatt. That was so informative and so helpful. Thank you. We have a question in the chat. It says the connection of PFAS to pregnancy-induced hypertension should provide some solutions to care. How much is the information appreciated in the maternal child space?
Well, that's a good question, and I don't know that I've got the expert answer to that, since I don't really work in that space. But I think you're probably really going to have to check with some of the experts that really deal in the pediatric space. In that National Academy document I told you about, there was a committee that did that, and there were a number of folks that were from in the pediatric medical space, and their names are all listed in the back of that. And I think I'd start there. Sorry, I can't give you a much better answer, but I really don't know how prevalent the information is and how people are utilizing that.
Okay, thank you. And we can get that reference to you. And thanks for explaining the Chevron decision in this application. And the same person that asked about the maternal child space also wrote, no problem. I was asking because sometimes research is in silos and coming together can solve many concerns. That is completely correct.
I think based on that comment, there is a lot of collaboration in the research between the providers and the researchers in this case, because I mean, the research is so relevant, and there seems to be a lot of communication, particularly in communities where PFAS has been an issue. The medical community and the research community have worked a lot together. There was one slide that showed a number of organizations that are heavily involved in this, and part of their mission is to make sure information gets disseminated to the people who ultimately are on the ground. And likewise, they want people in communities, providers in communities who identify potential issues to connect to the research, because they're looking for case studies and actual cases that they can help them uh, as a basis for their research.
So if there are no further comments or questions, we'll go ahead and end today's session. Again, Dr. Wyatt, thank you so much for joining us, and we might need to bring you in again when, as these things keep changing, there's updates made daily. So thank you again for your expertise on this subject.
Very good. Enjoyed being with you.
All right. Thank you all. Have a great day. Bye-bye.